Hi Math 2 and welcome to your first video of Module 3. So first we got to talk about vocabulary here. So a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. And then a power is when you raise something to a power, right? A power is an exponent, all right? So what they mean by monomial is just like one term, I guess. That's kind of to me, that's the best way to describe monomial is one term. So for example, if you had like 5 plus y, that's a binomial because it has two terms. This 5 plus y plus x would be a trinomial because it has three terms. A monomial would just be like x, right? It's got one term. All right, and then hopefully you're familiar with powers. That's when you're raising a base, and that means that you are going to multiply that base. So for example, 5 to the power of 2 is equal to 5 times 5. All right, if you had 5 to the fourth, that would be equal to 5 times 5 times 5 times 5, right? Hopefully we're pretty familiar with exponents, all right? So now we're going over the rules of exponents. I think you guys have seen this before. If not, no worries at all. So first we have product of powers. So if multiplying two numbers with the same base, you add the exponents. So keep that in mind. They have to be the same base, all right? But it's pretty simple. All you do is you add the exponents. So for this first example here, our base is 5, so you keep your base, and then you add your exponent. So I'm going to do 2 plus 6, which is going to give me 8. So I get 5 to the 8th power. Then let's look at example 2. All right, I'm doing y to the 4th times y to the 3rd times y. We're going to keep our base and add our powers. We got 4 plus 3 plus, and then this y, even though there's not a power there, that's an implied 1, right? So we have to put in a 1 there. We end up with 8, y to the 8th power. All right. So for example 3, all right. So before, none of these terms had numbers as coefficients of these variables that are being raised to the power. So if you look here, right, the y's, we got our y terms. Those guys we're going to do just like we've been doing, right? We're going to take our powers and add them. So we've got 5 and 1 is going to give us 6. So we're going to get y to the 6th. And then for these terms in front, you simply multiply them, right? We're multiplying these terms. You're going to multiply the coefficients here. You get a 42. So your answer should be 42y to the 6th. So to reiterate this, when you have a coefficient, you actually multiply the coefficients. And then the guys with variables, you add their powers. All right, next one. We're going to do the same thing. We are going to multiply our coefficients, which is going to give us a negative 15. Now, keep in mind, right, a big rule of this was that you can only do this with exponents of the same base. So what we're going to do here is we're going to combine the x's, right? We've got a 2 plus 1 is going to give us a 3. So we get we get x to the 3rd. And then for the y's, right, we're going to do 7 plus 6, which is going to give us 13. So we get y to the 13. All right, so to recap, we multiply the leading coefficients. And then when we multiply each of these terms, right, when you multiply things with exponents, you add their powers. All right, so now we've got dividing powers. All right, so if dividing two numbers with the same base, you subtract the exponents. Now, this is super important. When you do this, it is always the top minus the bottom. And a lot of people make a lot of mistakes with this. You always have to do the top minus the bottom. So keep that in mind because they do get a little bit trickier. So let's go ahead and look at example 5. So we're dividing things of the same base. We're going to take our powers, which are 6 and 1, and subtract them. Notice how I did top minus bottom. We would get y to the 5th. All right, next one. Same thing, right? We've got same base, which is a 6. We're going to do 13 minus 2. Top minus bottom is going to give us 11. We get 6 to the 11th power. Could you plug this into your calculator? Yes. Is it going to be a disgusting number? Yes. So just leave it as 6 to the 11th power. Next one. Now keep in mind, right, before when we had coefficients, we would multiply them when we were multiplying. Here we're going to divide when we're dividing, right? So 10 divided by 15. All right, is going to give us 1 over 3, 1/3. You could get like 0.33 repeating, but in these kinds of problems, I would leave them as fractions. All right, so leave your answers as fractions. So we've got our 1/3, and then we've got to do our A's and our B's here. So for our A, we're going to do 7 minus 5, which is going to give us 2. So we've got a squared. And then we're going to do 9 minus 4 for b, which is going to give us a 5. All right. And then the proper way to write this, when you're working with these, basically what I do is I get my answer. So we have like 1/3 a squared b to the 5th. And then I always ask myself like, okay, what's on top, what's on bottom here? So this 3 is in the denominator. So I would just put this all over 3. And then you have a 1 on top, but remember we don't really write a 1. So this would be the proper way to write the answer. A squared b to the 5th divided by 3. Now another acceptable answer would be 1/3 a squared b to the 5th. But that's not as nice, and I would definitely recommend doing it like this. And you'll kind of see why as we do more of these problems. All right. So any non-zero number with an exponent of 0 is equivalent to 1. Okay. And then this is a super important property. So anything raised to the 0 power, anything, okay, any non-zero, so basically any number other than 0 raised to the 0 power is going to give you a 1. All right. And why is that? Well, let's think about it. Okay. If we did 8 over 2 divided by 8 over 2. Well, anything over itself is going to give you 1, right? If I did like 1,000 to the 1,000th power over 1,000 to the 1,000th power, that would also give us 1 there, right? But let's think about it this way. All right. If we actually simplified this guy, we would get 2 minus 2, which gives us 0, right? So we'd have 8 to the 0 power, which should also give us 1. So this is kind of explaining why this works. The takeaway here is that anything raised to the power of 0 is going to be 1. So if we're looking at example 8, we got all this nonsense raised to the power of 0. I don't even know what x is. I have no idea, right? But your answer here is just going to be 1, because anything raised to the power of 0 is going to give you 1. All right. Next one. Now, if we look here, this x to the 0 can be simplified to 1. So we get 8 times 1 plus 5. 8 plus 5 is going to give us 13. That would be our answer there. All right. Now we got a non-negative exponent. Okay. So for any non-zero number a raised to the negative exponent, place the power in the denominator to rewrite the power with a positive exponent. We always leave our powers with positive exponents. Okay, so basically what they mean is that anything with a negative exponent can get booted down to the denominator and become positive. So for example, if we had x to the negative 5, we don't like having negative powers. That's just something in math we do not like. So the way you would write this would be x to the 5th. Or I'm sorry, 1 over x to the 5th. All right, when you boot it down to the denominator, the power changes. The same thing happens. Let's say I had something that was in the denominator. So we'll say x to the negative 6th. All right. Notice how it's negative and into the denominator. Well, I got to bring that back up. That would be x to the 6th power. All right. All right, so let's go ahead and try example 10 here. We've got 2 to the negative 3. So we're going to move that 2 into the denominator and its power becomes positive. All right. Let's go ahead and try number 11. So we've got negative 3 to the negative 3 power. It's going to be 1 over negative 3 to the 3rd power. All right. This one you actually could simplify. You could get 1 over negative 27. That's also acceptable. I don't care which one you put. All right. Then we've got what happens when you multiply exponents. All right. So when you multiply exponents, you've got the guy on the inside and the guy on the outside. Or I'm sorry, when you raise, I apologize, I misspoke. What happens when you raise a power to a power? All right. So this means that you have something with a power being raised to a power. What you do is you just multiply those powers. All right. So x squared to the 8th power is going to give us x to the 16th. Y to the negative 3 to the power of negative 4 is going to give us y to the 12th. All I did here was multiply these guys. All right. Power of a product. Find the power of each factor in the parentheses and multiply. All right. So what they mean by this is tricky, but it's not too bad. When you are raising stuff that's being multiplied to a power, basically what you end up doing is like distributing this power to each term. Okay, and in order for you to do this, it has to all, everything on the inside has to be getting multiplied. All right, so notice how it's 4 times x cubed times y times z. If you had like 4 plus x, you could not do that because it's not being multiplied on the inside. Everything needs to be getting multiplied on the inside to just distribute that, that exponent. So this you get 4 to the third, x to the 9th, y to the third, and z to the third. All right. We could get the actual 4 to the third power. That is going to give you a 64. So you get 64, x to the 9th, y to the third, z to the third, right? And how did I get that 9? Well, since I had a power being raised to the power, I multiplied. Same thing here. These are both 1, so 3 times 3 gives you 9, 1 times 3 gives you 3, and 1 times 3 gives you 3. All right, number 15. We are going to go ahead, since everything is being multiplied on the inside, we can go ahead and distribute this. So we get 7 to the negative 2, y to the negative 2, and, I'm sorry, x to the negative 2, and y to the 4th. All right, so now this is very important. Pay very close attention to how I do this. Now, in this problem, we have some positives and negative exponents. So when we rewrite this, since I have both positives and negatives, I'm going to make my fraction bar. My positive powers are going to go on top. My negative powers are going to go onto the bottom and become positive. All right. Then we've got 16. So again, distribute that negative 2. 6 to the negative 2, x to the 12, y to the 14th, and z to the 0 power. All right. So at this point, I would make my fraction bar because I got both positives and negatives. All right. X to the 12 is going to go on top. Y to the 14th is going to go on top. Now this z to the 0, right? Remember, anything to the 0 power gives us 1. This is equivalent to 1, so he kind of just goes away. And our 6 squared is going to go on the bottom. And we can rewrite that as 36. All right. So this last one is called power of a quotient. So for any numbers a and b where b does not equal 0, the quotient of a and b is raised to a power. Raise both the numerator and the denominator to the given power. So what they mean by that is if you have something that's a fraction, okay, and that fraction is being raised to the power, you kind of quote unquote distribute that to both levels of the fraction. So if you had a over b raised to the power of m, you would get a to the m over b to the m. All right, so let's take a look at example 17, right? So we have a quotient, right? It's something that's being divided. You have to raise the top power and the bottom power to 5. So you would get 3 squared and 5 squared, all right? You could actually write this one out because it's like a nice answer. You'd get 9 over 25, all right? I'd be happy with either of these. I'd say, when the powers are low, you can actually, get the actual powers. But, if you had something crazy like, 3 to the 100, please don't plug that into your calculator. Just leave it as 3 to the 100th power. All right. So next one. So we're going to go ahead, distribute this. Now, keep in mind, right, before if we just had something that was like 2a to the 5th, you still had to distribute it to each term, right? So that's what we're going to do here. We have to distribute this 2 to each term, both on top and the bottom. So we would end up with 2 squared, a to the 10th, and b to the 14th. Now 2 squared we can write out because that's a nice one. So we would get 4a to the 10th over b to the 14th. All right, next one. So again, we're going to distribute that power. So we get 3 to the 3rd, a to the negative 12, and b to the 21. Now, keep in mind, we do not like having negative powers. So we got to boot this guy down into the denominator. So we are going to get 27 over a to the 12th, b to the 21st. Now let's go ahead and distribute this negative 6. So we end up with a to the 12th, b to the 30th, and c to the 66th. Now notice how these are all positive powers, so we're good to go, right? We just get a to the 12th, b to the 30th, and, c to the 66th.